Video we will be discussing about liquid limit of soil. So liquid limit is an important index property of soil which is defined as the water content at which soil changes its state from plastic state to liquid state, or the soil turns into a liquid and it loses its shear strength. So this water content is very important since the soil is changing its state and it is losing its shear strength. So to find the liquid limit in laboratory we can perform two tests. One is the Casagrande test and another is the cone penetration test. In this video we will be discussing about Casagrande test, that how we can perform this in laboratory and determine the liquid limit of soil. Physically, we mean that the soil has changed its state from plastic state to liquid state. But how we will determine it in laboratory? For this, a particular definition has been given, as the liquid limit is the moisture content at which groove formed by standard tool into the sample of soil taken in standard cup closes for 12 on being given 25 blows in standard manner. So what we do is we take a Casagrande apparatus for liquid limit test and put our soil sample in it. Before that, the soil is passed through 425 micron sieve, and this fine grained soil is used for this liquid limit test because liquid limit is defined only for fine grained soil, and for coarse grained soil liquid limit is not defined. So the first step is to pass the soil sample through 425 micron sieve, and after passing it through 425 micron sieve, the amount of soil that has passed through the 425 micron sieve is taken, and water is added to it, and a paste is formed. After that, this is put in the Casagrande apparatus. Here is the cup of Casagrande apparatus. This golden color bowl you are seeing, it is called Casagrande cup, and here it is the machine has a rotating handle which is revolved so that this cup raises by about 1 centimeter and falls on this pad. This is the pad of the Casagrande apparatus, and here we have the in this portion we have an arrangement to record the number of revolutions given to this handle. And in this cup, Casagrande cup, the soil sample is put, and from the middle it is stored into two parts, and then it is the number of blows required for 12 closure are noted. So basically, what we will do, we will take the soil paste that is formed earlier by adding water into the soil, and put this in this Casagrande cup. And now we can use these two grooves, standard grooves, grooving tools, to make a groove in this soil sample. If it is a fine grained soil, that is silt or clay, we will use this Casagrande tool, this above one in golden color. Otherwise this one in silver color is used for fine sands. This is known as ASTM tool. So in case of fine sand we will use this tool, and in case of silt and clay we will be using this tool that is known as Casagrande grooving tool. So basically, above below 75 micron, that is silt and clay, this tool will be used to make this groove. And the for particles between 75 micron and 425 micron, this ASTM tool will be used. So after putting the soil in this soil paste in this cup, a groove is made in the center of this cup, so that the soil is divided into two parts. And now from the handle revolutions are given until these two soil parts move together for 12 mm. They should not slide but move, and revolutions are given at the rate of 2 revolutions per second, and it is seen that these two soil parts move together for 12 mm. At that point we measure the number of revolutions taken in this digital reading meter, and we can get this the number of blows required for 12 mm movement of the soil. So we note two things. One is the water content and number of revolutions taken for the two soil parts to move together for 12 mm. If they come exactly as 25, then that water content is considered as the liquid limit of soil. Otherwise, we will do a number of tests by changing the moisture content of soil or water content of soil again and again, and note the number of blows each time required for 12 mm closure or movement of two soil parts together. After that, we have the readings of number of revolutions and the water content of soil. So we will prepare a graph between them. On the x-axis, we have number of blows, that is on logarithmic scale, and on the y-axis, we have water content or moisture content of soil. When this graph is prepared on log scale, a straight line will, the points will fit to a straight line. We will draw a best fit straight line through these points, and then corresponding to the 25 number of blows, here you can see 25 number of blows, we will move towards the graph, and from there we will move horizontally and determine the water content. This water content corresponding to 25 number of blows is then taken as the liquid limit of soil. So this liquid limit of soil is this curve is known as the flow curve, and this is used for determining the liquid limit of soil. At each basic observations are for each water content we have to determine the number of blows. So we have to measure two things in laboratory: number of blows and the moisture content. To measure the moisture content or the water content of soil, we can use any method. Most commonly oven drying method is used. A link for that video is also available in the end screen of this video. Thank you for watching our video. Please subscribe to the channel, like and share the videos.